Figure shows a thin uniform square metal sheet of side length side A with a square hole of side B in it. A and B are of the order of few centimeters. Especially we have to consider that it is about few centimeters. A, B, thickness T and mass M of the sheet are to be measured as accurately as possible. Part A. What is the best laboratory measuring instrument that can be used to measure T? T is the thickness of the given metal sheet. When measuring the thickness, we are using micrometer screw gauge. Then we can write answer for part A, micrometer screw gauge. Then part B, an important check has to be made before taking measurement using the above instrument. What is it? We have to consider zeroth error. Then we have to check the zeroth error of the instrument. Then we can write answer for part B, zeroth error. Then part C, you are given a vernier caliper to measure A and B. Which part of caliper would you utilize to determine A and determine B? A means external length. We can measure it by using external jaws. Then we can write C part 1. When measuring A, we have to use external jaws. Then part 2, determine B. B is the length of the hole. When measuring length of the hole, we can use internal jaws. Internal jaws. Then part D, what is the most suitable laboratory instrument that can be used to measure simple M? We can use electronic balance. To measure the mass of the given metal sheet. We can use 4-beam or triple beam balance, but best answer is electronic balance. Now we are using electronic balance to measure a given mass to high accuracy. Then part E, write down expression for the density of the metal in terms of M, A, B and T. We can write expression for the density. Density is mass divided by volume. We have obtained mass as simple M by using electronic balance. We have to substitute volume by using given measurements. I will consider the given metal sheet like this. There is a hole inside the metal sheet. Therefore, we can subtract this smaller cuboid, this one, from larger cuboid. We can get volume of larger cuboid, length side A, external length is A, then we can get A into thickness, length A breadth also A, thickness is T. It is the volume of large cuboid. Then we can consider volume of small cuboid. Its length and breadth B, B into T. Then we have to subtract this expression and this one to get the volume. And we can simplify it. We can write volume. I will get T as a common factor and then we can write A squared minus B squared. Then we can write volume. We can substitute volume for the equation. T times A squared minus B squared. Then part F. The thickness T was measured at 5 different places of the sheet and the value obtained are given below. 1.10 millimeters, 1.11 millimeters, 1.12 millimeters, 1.12 millimeters and 1.11 millimeters. Part 1. What is the least count of the measuring instrument used? We can consider given measurements. All given values are up to second decimal place. Therefore, the least count of the measuring instrument should be 0.01 millimeters. We can obtain up to second decimal place in millimeters. Then part 2, calculate the mean thickness of the sheet. When calculating mean thickness, we have to add given all values. There are 5 values. We can get thickness 1.10 plus 1.11 plus 1.12 plus 1.12 plus 1.11. There are 5 values, then we have to divide it by 5. I will add it. 0 plus 1, 1, 1 plus 2, 3, 3 plus 2, 5 plus 1, 6. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. 1, 2, 3, 4, 5. 5.56 divided by 5. Now we have to divide. 5 divided by 5, 1. 5 divided by 5, 1. 6 divided by 5, 1. Remaining 1. If we simplify it to the next decimal place, we can obtain 2. It is less than 5. Therefore, we can write rounded off value up to second decimal place is 1.11 millimeters. It is the correct answer. We have to remember that the least count of the measuring instrument is 0.01 millimeters. Therefore, we can get all readings and all calculated lengths up to second decimal place. We can't give the answer with 3 decimal places. Then answer is 1.11 millimeters. Part 3. Up to how many decimal places would you give the answer calculated above? Explain why. You can write part 3, F part 3. Up to 2 decimal places because of least count is 0.01 millimeters. Then part G. To determine the volume of the sheet, a student suggests to immerse the sheet in water and measure the volume of water displaced. State why this is not so accurate as compared to the value calculated using A, B and C. The given method in part G is accurate, but there is a problem related to this experiment. Because of this A, B, T values are small values. Therefore, displaced water volume is a small one. Therefore, there is a high percentage error. Then we can write displaced water volume is a small value. Therefore, percentage error is a higher value. Or we can write therefore there is a high percentage error.